Okay, now look at it this way. Suppose I have got yt is equal to 2. Okay, and suppose ET is a white noise process. Suppose ET is a white noise process. You know that the long-term mean of YT is 4, right? So that is your unconditional forecast, right? But I might argue to you that look here, I know that the conditional mean of y, conditional upon yt minus 1, that is if I know yt minus 1, suppose yt minus 1 is 10, then I expect yt to be 2 plus 0.5 into 10 plus et. Yt will be 2 plus 0.5 into 10, so 2 plus 5 plus et, so 7 plus et. So expected value of yt is 7 because expected value of et is 0. How did that 7 come? Because yt minus 1 was 10. If yt minus 1 were 20, then this will be 10 plus 2, 12 plus et. Yt will be 12 plus et, and therefore the conditional mean of yt will be given yt minus 1 will be 12. So what you can say is, there is another way of conceptualizing the average value of yt, conditional upon what value yt minus 1 takes. And that is equal to, so this is say alpha plus 5 yt minus 1 plus et, that is simply alpha plus 5 yt minus 1. So I can say tomorrow's value of yt is likely to be not 4 but 12, because yt minus 1 was 10. Okay, yt minus 1 was 10. So my forecast is this. So this is my ft, right? So what is my yt? My yt is my ft plus e, right? Because this part is ft. This part is ft. Actual value of yt is my forecast value of yt plus an error term e. Sure? What is the expected value of yt then? Yeah? So on an average, this forecast is also correct. Yeah? So this is also an unbiased forecast. So which one do you prefer? Given two forecasts are unbiased, you must prefer the one which has a lower variance, which is more accurate. Both of them are correct on an average. If there are two forecasts which are correct, both of which are correct on an average, you must choose the one which has a lower variance. So what is the variance of yt? Variance of this forecast? Variance of this forecast is, so clearly the variance of yt here is, okay, what will you have? Variance of yt, expectation yt minus ft square, which is what? Which is expectation et square? What is expectation et square? Variance of et. So it is, so the variance of this for one period ahead forecast, the variance of this conditional one period ahead forecast is sigma square e. Whereas what was the variance of the unconditional forecast? Sigma square e upon 1 minus phi square. Now if phi is a quantity less than 1, 1 minus phi is a quantity less than 1. So there it was sigma square divided by a quantity less than 1, which means sigma square multiplied by a quantity greater than 1. So that variance will necessarily be larger than the variance here. Right? So if you have just a one period conditional forecast, then also be unbiased, but that will be more precise compared to the unconditional forecast. Is this clear? More precise compared to the... Why? Because you are using more information. Here you are using the information that you know what is yt minus 1. There you are not using any information. So this forecast is based on more information. Therefore, it is a more informative forecast. Therefore, it is more accurate. There is more information in this forecast. Okay, so I do this. I forecast for yt. I am very happy. मेरा correct आ गया. I got a better forecast. So I decide to forecast also for yt plus 1. अभी मैं एक दिन से नहीं 2 दिन का forecast करूँगा. Now let us see. 2 दिन का जब करता हूँ तब क्या होता है? तो 2 दिन का जब करता हूँ, I know only yt minus 1. I don't know yt and yt plus 1. मैं yt का भी forecast करूँगा, yt plus 1 का भी forecast करूँगा. Right? So yt plus 1 is alpha, right? Sure? Okay? This is what yt plus 1 is. This can be written as yeah, because yt भी मालूम नहीं है तो yt का तो previous value substitute करना पड़ेगा. Yt is equal to alpha plus 5 yt minus 1 plus et, right? So this becomes right. Now what do I know? I know alpha, I know phi, so I can calculate this, I can calculate this, I can calculate this, I know what is yt minus 1. So this is my forecast. Ft. Right? Alpha plus alpha phi plus phi square yt minus 1. Right? So what is my forecast error? Yeah? Sure, phi et plus 1. That's my forecast error. Yt, no, yeah, so this is my forecast yt plus 1, yeah, sorry. Yt plus 1 minus ft, right? Ft minus 1 because ft plus 1 will write it like this because forecast for time period t plus 1, right? Which is phi et plus 1. So इसका variance क्या होगा? This, right? Sure? Which is the variance of this plus the variance of this? Which is what? Phi square sigma square e plus sigma square e is equal to, yeah? Whatever the value of phi, this has to be greater than sigma square e. But this is still less than sigma square e upon 1 minus phi square. Can you tell me why? This will be greater than sigma square e because it is 1 plus phi square into sigma square e. Phi is some positive quantity, it's negative, phi square will still be positive. So 1 plus phi square sigma square is greater than sigma square e. But tell me why this will still be less than sigma square e upon 1 minus phi square. Why? Because sigma square e upon 1 minus phi square कैसे आया? We actually had the sum, no? Sigma square e plus phi square sigma square e plus phi square square sigma square e plus phi square cube sigma square e. It was the limit of that full sum. Whereas here we are only adding sigma square e and phi square sigma square. So we are only adding two terms of that sequence. Right? Sigma square upon 1 minus phi square was the limit of that whole sequence. So therefore this is still less than that. But more than the 1 period ahead forecast. So the 2 period ahead forecast will be less accurate compared to the 1 period ahead forecast, but still be more accurate compared to the unconditional mean forecast. Why is it more accurate? Because we are using more information, using yt minus 1. But why is it less accurate than a 1 period ahead forecast? Because the knowledge of yt minus 1 is relevant to yt, but less relevant to yt plus 1 because the impact of what happens on yt is going to die out in time. So if I know yt, it helps me know yt plus 1. It helps me to know yt plus 2 also, but not as much as it helps me to know yt plus 1. Because now I am looking at further and further and further future periods ahead, the impact of yt will die out because phi is less than 1 absolute value for a stationary process. Right? So if I do this, if for example I do a 3 period ahead forecast, you will realize that yt plus 2 will be nothing but alpha, yeah? You say something? Alpha plus alpha phi square plus alpha phi cube, right? It will go like this. Alpha plus alpha phi square plus alpha phi plus alpha phi square. It will go like this. Alpha phi square plus it will go like this. it will go like this, right? And the variance of the forecast error will be, sigma square E plus 1 plus phi square plus phi square square. This will be sigma square E, this will be phi square square. Now if I do this j periods ahead, then what will I get? I get alpha plus alpha phi square plus alpha phi cube, etc., which will converge to alpha upon 1 minus phi. Right? If I do this, think of this instead of think of this as j. Okay? So instead of this, think of yt plus j. Is this clear up to so far? So if you forecast 3 periods ahead, the variance will be even larger. The point that I am trying to make here is, and it's an important point to realize, and something that the detail of it you need to work out on your own, okay, as a part of. So if I generally forecast j periods ahead, I know only yt minus 1. If I forecast j periods ahead, my equation will be yt plus j is equal to alpha plus alpha phi square, alpha phi cube, alpha phi raised to j, right? Plus phi raised to j plus 1, yt minus j plus yt minus 1, right? Phi raised to j plus 1, yt minus 1 plus like that. Sure? Now as j tends to infinity, as I keep on forecasting further and further ahead, this part will simply become alpha upon 1 minus phi, because this will be a geometric series. Phi raised to j, this part will tend to 0, and what will remain is et plus phi, et plus 1 plus phi square, et plus 1, etc., etc. So I will get plus et plus phi, et plus 1 plus phi square, et plus 2 plus phi cube, et plus 3, and so on. Right? So the forecast error will be, the variance of this will be like that, right? Which you can easily see the whole square. Which you can easily see is the square of this plus the square of this plus the square of this, which will be nothing but sigma square into 1 minus pi square. So, as you forecast very far ahead, your conditional and unconditional forecast will become identical. Why do you think that will become? Because as you forecast very far ahead, why was the conditional forecast better than unconditional forecast? Because you had more information. You knew yt minus 1. So yt का forecast अच्छा था, yt plus 1 का अच्छा था. But as you keep on forecasting very far ahead, the relevance of knowing yt minus 1 becomes pointless. Because the process is stationary, so the impact of yt minus 1 is going to die off over time. Right? So the relevance of knowing yt minus 1 is going to become unimportant as you keep on forecasting further and further. So in the end, if you forecast too far ahead, the information content in your conditional and unconditional forecast is going to be identical. And therefore the forecasts too are going to be identical. So the point is, if you have a conditional forecast, if you are forecasting further and further ahead, you are not going to forecast what will actually happen. You are only going to get closer and closer to the mean of the series, the unconditional mean of the past data that you have. Right? That's something which you must remember. You can't blindly use formulae to predict things. Okay? Fine? So this is something which I wanted to explain to you. Right? So with this we are done, folks. Right? Hope you have enjoyed this course. And now start cracking. Mayank will of course deal with you on Saturday in the remedials. But if you have any doubts, please feel free to contact me either in my office or you have my email neeraj.hatekar@gmail.com, nwraj.hatekar@gmail.com. Please feel free to send me a message or feel free to send me a message on YouTube where you can put a comment.